Greetings, ladies and gentlemen. This is Miss Anne Michael Lim, and I will be showing to you the distance formula, how to derive it, and some examples in finding the distance of 2 points. Okay. Now, we have this Cartesian plane, and given the points x sub 1 and y sub 1 and points x sub 2 and y sub 2. We now want to determine the distance between these 2 points denoted by d. Okay. As we can see, we can create a right triangle from these 2 points. We just have to determine the dimensions of this triangle so we can compute for the formula of the distance between these 2 points. Okay, now let us observe. We know that looking at the x-axis, we have this one. We know that this one has x sub 2 units. Okay, same with this one. For this part, we have this one as x sub 1 units. Okay, and now, since this is x sub 2 units, this whole thing, and this one has x sub 1 units, and we want to know the dimension for the base or the measure of the base for this triangle, which is just equal to this one. So, observing it, we know that this part here, or the base of the triangle, is just x sub 2 subtracted by x sub 1. So, we can get this one. So, x sub 2 minus x sub 1. Similarly, to determine the height or the other leg of the right triangle, which is just this one. So, for this one, this is y sub 2 units, meaning there are y sub 2 units to get to this one. And for this one, this has y sub 1 units. Okay, to get this one, this part, this is just y sub 2 subtracted by y sub 1. So, this is y sub 2 minus y sub 1. Okay, now we have the dimensions of the right triangle, and using the Pythagorean theorem, we can now have d squared, which is our hypotenuse, is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, and extracting the roots, we now get d, or the distance, is just equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is now our distance formula. For example, we are tasked to determine the distance between the 2 given points, 3, 1 and 5, 4, using the distance formula, which is d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We know that for this point, we have 3 as our x sub 1 and y, or 1 rather, as our y sub 1. Similarly, 5 is our x sub 2 and 4 is our y sub 2. Now, substituting the coordinates to the given formula, we have d is equal to the square root of x sub 2, which is 5, minus x sub 1, which is 3, squared, plus y sub 2, which is 4, minus y sub 1, which is 1, squared. And computing, we get this one as 2 squared plus 3 squared. 2 squared, which is just equal to 4, plus 3 squared, which is equal to 9. So 4 plus 9 is equal to 13. So the distance between points 3, 1 and 5, 4 is the square root of 13. Another example is to determine the distance between the points 2, 5 and 3, 2. So substituting again the coordinates of these 2 points to the formula, we have d is equal to the square root of 3, which is our x sub 2, minus 2, which is our x sub 1, squared, plus our y sub 2, which is 2, minus 5, which is our y sub 1, squared. This is just equal to 1 squared plus negative 3 squared. Okay? So 1 squared is just 1 plus negative 3 squared, which is equal to 9. So our distance is 1 plus 9, or the square root of 10. For our last example, we have to determine the distance between the points 5, 4 and 9, 7. So, again, substituting the coordinates of these 2 points to the given formula, we have the distance is equal to the square root of our x sub 2, which is 9, minus x sub 1, which is 5, squared, plus y sub 2, which is 7, minus y sub 1, which is 4, squared, is equal to the square root of 4 squared plus the square root of square root of 4 squared plus 3 squared, which is just equal to the square root of 16 plus 9, which gives us the distance of square root of 25, which is just equal to 5. So the distance between the points 5, 4 and 9, 7 is 5. That would be all. And this is Miss Lim again. And thank you for watching.